So for ions, we have a nice equation here with the Debye-Huckel theory that lets us calculate activity coefficients. What about not ions, right? What about other things that are present in solution? So we can have non-electrolytes, things like glucose, sugars that can dissolve, for example. For non-electrolytes, for our purposes at least, in general, you do need to use activities for everything, and you can calculate them. But for non-electrolytes, for our purposes, we will assume that the activity is approximately just equal to the concentration, and just use the concentration directly, not worry about activity coefficients. And honestly, for most cases for this class, we're mostly going to ignore activity coefficients for the vast majority of things we're going to consider. But occasionally it does matter, and it's important to know that activity coefficients exist, and depending on the application you're looking at, it may be very important to what you're doing. Okay, so non-electrolytes in solution, we just assume it's equal to the concentration. For gases, if we're thinking about an equilibrium involving gases, we can write that the activity is equal to an activity coefficient times the partial pressure. And in general, this will be in bar. This actually gets its own special name. The activity for a gas is known as a fugacity. And this is sort of, looking for its behavior compared to an ideal gas. So when things behave not like an ideal gas, then these coefficients matter. And this is called a fugacity coefficient. But essentially, it's the same idea as an activity. And for our purposes, we're going to assume that this is equal to 1 and that gases behave ideally. And under sort of normal circumstances, atmospheric pressure, that's a very good assumption. So unless you have some really weird gas or really high pressures, generally these don't matter. And then for liquids and pure liquids and solids, the activity is equal to 1. And that's something we've already assumed for all of our equilibrium calculations. But that, you can show that for pure liquids and solids that the activity coefficient, or the activity, I should say, is equal to 1. And so they're not going to show up in our equilibrium expressions, which you're already used to. So that is how we deal with anything that's not an electrolyte. And in our final video for Chapter 8, we're going to look at an example of actually using activity coefficients in a solubility product calculation to show how you would actually use this in an equilibrium calculation.